Good morning, everyone, and welcome to this lecture. We are dealing with work done by a force, and in the previous class, we had seen work done by force in various cases. We had seen the work done by different forces. We had seen work done by gravity. Do we remember this work done by gravity, which is a conservative force? It does not depend on path. It only depends on the height or the distance or height it has moved. When it moves down, work done by gravity is positive. When it moves up, the work done by gravity is negative. And it does not matter how you are moving it, whether it is falling vertically down or it is falling on a slide, work done by gravity remains same. Do we understand this? We remember this? Then we had seen that we can also find work done by using the dot product. When we have to find out the dot product, we just simply multiply I by I, J by J, and K by K. Yes or no? We will continue on this in this class, and we will see more examples of it, because what I feel is that you might get a question based on this. So I'll give you one or two more questions on this. So this is the next question that is going to come. Again, it is taken from one of your previous exams. So I hope that you are able to solve this. The question is pretty simple, and the question comes on your screen right away. A force 5i plus 3j. Remember, in your exam, you might not get a three-dimensional force. I have given you the example of three-dimensional force, but in exam, you might only get two-dimensional force. This is a two-dimensional force. A force 5i plus 3j is applied over a particle which displaces it from the origin to a given point. Force is in newtons, displacement is in meters. You have to find out the work done on the particle, and you have 2 minutes to solve it and get the answer. It's a simple, straightforward question, and I hope you will be able to do this. I'll wait for your answers. Just bacha.
Option C, sir.
Option C is what we have got. Just let me, I'm just opening up. Option C, +7. Is that the answer everyone is getting? And that is correct. How are you doing it? Everyone remembers how to do this? You have to take the dot product here. And how do you take the dot product? I have already told you how to take the dot product. This I will get multiplied by this I, and this j will get multiplied by this j. So 5 into 2 is 10, 3 into -1 is -3. So the answer that you are going to get is going to be +7. Do we understand this, everyone? Yes or no? Anyone got this answer?
Yes, sir. Yes, sir.
Okay. Shall we move on to the next question? Yes or no? No or yes?
Yes, sir.
Okay. So here is the next question. Again, it is taken from one of your previous papers. And here is the question on your screens. Now, a uniform force of 3I plus J Newton acts on a particle of mass 2 kg. The particle is displaced from the position 2I plus K to the position 4I plus 3J minus K. Oh, what is the work done by this force on the particle? So let us see if you can give me the answer for this one. You have 2 minutes to do this. Something is different in this question. You have to find out what is that difference. If you can understand that difference, you will get the answer straight away. I'll give you 2 minutes. Else I will help you out. Do we have any answer for this? Okay. How are you supposed to do this? Well, the particle, it is given that it is displaced from this position. So this green one becomes its initial position. The particle is initially here. Then is displaced to the position of 4i plus 3j minus k. This is the final position. So here the particle's initial and the final position is given. So first thing that you have to do is to find out the displacement of the particle in vector form. What is the displacement of the particle? It is final position minus initial position. So what you have to do is subtract the initial position from the final position. The final position is 4i plus 3j minus k, and you have to subtract 2i plus k from there. So how do you subtract? From I you subtract I, from j you subtract j, from k you subtract k. So what will you get when you subtract? 4i minus 2i becomes 2i, 3j, there is no j on that side, so it remains 3j, minus k becomes minus 2k. So this is my displacement of the particle. This is how you have to find out the displacement if the initial and the final position is given to you. Do we understand this? Yes or no? Do we understand this? Well, then now what you got to do is to take the dot product. This 2i will get multiplied by this 3i. This 3j will get multiplied by this j. And for this k, we don't have any k, so it will get multiplied by 0. So now can you tell me the answer? Now can you tell me the answer? What is the answer?
D, sir.
Answer is D, sir. 9 joules. So this is how you have to solve the problem if the problem has initial and the final position. You have to find out the displacement. How do you find out the displacement? You subtract the initial position from the final position, and then you get your displacement. I'll give you 1 minute to note this down, and then we will move on to the next question.
Completed, sir. Completed, sir.
So now we have this question for you. A force 2i plus 3j displaces a particle from one position to the next position. You have to find out the work done by this force, and I'll give you 2 minutes to give me the answer. Do we have an answer, anyone? No one? Okay. So first of
9
all,
joules, sir.
yes, beta?
9 joules.
9 joules. Okay, I don't know the answer, so I'll just find out. So first of all, I have to find out the displacement. How do I find out the displacement? I think you can multiply. You have to subtract 4i from 3i. 3i minus 4i, so that will give me minus I. You have to subtract minus 4j and j on that side. There is no j on that side, so it becomes minus 4j. Then you have to subtract minus k from 2k. So 2k minus of minus k, so that becomes plus 3k. So this is your displacement. Everyone got this? Yes or no? Did we get the displacement right? Yes or no? Then you just have to take the dot product. This minus I will get multiplied by this. So it will be minus 2. This minus 4j will get multiplied by this. So it is minus 12, minus 2, minus 12. And your work done would be minus 2, minus 12. So it is minus 14 joules. Anyone got this answer? No one got this answer? Anyone got this answer, beta? I'm asking you something. Anyone got this answer?
No, sir.
What was wrong? Where did you go wrong? In which calculation? Okay, we move on to the next question. A force F, which is equal to 3i minus 4j displaces a particle. And I want answers from everyone in this class now. So I'll ask the mic to be passed to each and every student, and each and every student will tell me their answers. A force F is equal to 3I minus 4J displaces the particle from 2, 1, 1 to 1, 3, 4. Find the work done. So everyone will have to tell me their answers for this question, right or wrong, doesn't matter. But everyone will have to tell me the answer. So the mic will pass on from one student to the other student, and every student is going to tell me the answer. So be ready. You have 2 minutes to give me the answers. Sorry. Let me correct myself. I think I have done the previous question wrong. Sorry for that. What I have done is I have subtracted the final position from the initial position. So I have done it wrongly. I must apologize. Uh, I must subtract the initial position from the final position and not final position from the initial. So I've done a mistake, a genuine mistake. So I have to subtract 4i is the final position and 3i is the initial position. So it should be 4i minus 3i. So it becomes I. Then there is nothing on that side for j. So I have to subtract 0 minus 4. So that is plus 4j. Then from minus k, I have to subtract minus 2k. So it becomes minus 2k minus k minus 2k. So it becomes minus 3k. So the answer instead of minus 14 will come as plus 14 joules. So I did a mistake there. I subtracted the final position from the initial position. I had to subtract the initial position from the final position. So that was the mistake. So now move on to the next question. And I hope you and me do not commit the same mistake again. This is the question. The initial position is given as 2, 1, 1. The final position is given as 1, 3, 4. I'll give you 2 minutes. Everyone will have to tell me their answer this time. So how this question has to be done? Anyone could do this? So here the position is not given in terms of vector, it is given in terms of coordinates. Doesn't matter. We can do the same thing. This is the initial coordinate, the pink one, and this is the final coordinate, the green one. How do I get the displacement? I subtract the initial coordinates from the final coordinates. The initial coordinate of x is 2, the final coordinate of x is 1. So I subtract the initial 2 from 1, so it is 1 minus 2. So 1 minus 2 is minus 1, so I get minus I. Then I subtract the y coordinate 1 from 3. 3 minus 1, 3 minus 1 becomes 2, so it is plus 2j. Then I subtract the initial z coordinate from the final z coordinate. 4 minus 1, 4 minus 1 is 3, so 3k. Then I will have to find out the dot product. This will get dotted with this, and this will get dotted with this. So minus 3, oh sorry, minus 1 dot with 3 becomes minus 3. So the work done is minus 3, and 2 with dot with minus 4 becomes minus 8. So the answer becomes minus 11 joules. This is how you need to do it. You have to see the initial coordinates, you have to see the final coordinates, you have to subtract the initial coordinates from the final coordinates, and then you need to take the dot product. Do we understand this? I'll give you one last question on this, and I hope that all of you can do this question, and all of you should be able to tell me your answers. If you don't get an answer, you will have to tell me what you have done. Is it okay to everyone?
Sir, can you explain again the question?
What did you don't understand? Tell me what you did not understand here, beta.
Sir, the initial coordinates.
You you can't. The initial coordinates are 2, 1, 1. What you don't understand? 2 is the x coordinate, 1 is the y coordinate, and 1 is the z coordinate, x, y, and z. You understand that?
Yes, sir.
Then you understand the final coordinates. 1 is the x coordinate, 2 is 3 is the y coordinate, and 4 is the z coordinate. We understand this. Then we have to subtract the initials on the final. You have to subtract 2 from 1. You know how much you will get? That is the x1. Then you have to subtract 1 from 3. 3 minus 1, 2. That is the y coordinate. Then you have to subtract 1 from 4. That is 3. That is the z coordinate. What is there you don't understand? Tell me. You understand how I, you understand
Understand, sir.
you understand how I got this? Yes or no?
Yes, sir.
Subtract the initial coordinates from the final coordinates, and then you take the dot product. Is it okay now?
Yes, sir.
Okay. I hope that you can do the next one, which is the final one in this category. So comes the next question. A force F, which is given as I minus 2j plus 3k, displaces a body from initial coordinates 0, minus 1, 2 to final coordinates 2, 1, 0. Find the work done. Remember, the first coordinate that is given is always x. The second one which is given is y. And the third one which is given is z or z coordinate. I'll wait for 2 minutes. Everyone will have to tell me their answers.
8 joules, sir.
Well done. I have an answer. Good. 8 joules. So first of all, let us find out how to do this. You have to look at the initial position and you have to look at the final position. For x coordinate, the initial position is 0 and the final position is 2. So you have to subtract 0 from 2. Let me write it. The displacement will be 2 minus 0. 2 minus 0. This is 2i. Then the final position is 1. Initial position is minus 1. 1 minus 1 becomes 2. So it becomes 2j. Then the final position is 0 for k and the initial position is 2. So 0 minus 2, 0 minus 2 also becomes minus 2k. This is what I get as displacement. Now I have to simply multiply 2 multiplied by 1. 2 multiplied by 1 is 2. 2 multiplied by minus 2 is minus 4 and minus 2 multiplied by 3 is minus 6 and the answer that I get 2 minus 4 minus 6 is minus 8 and that is the answer for this one. I'll give you 2 minutes to write this. Anyone understands this? Great. Let me know once you are written so that we can move on. Have you noted it down, everyone? Yes or no? Well then, we move on to how do we find out the work done by variable force. Remember the small amount of work done dW is F dot ds or dr, whatever you call it. This is the small amount of work done. To find the total amount of work done, you have to do the integration of F with ds. So this is how, by the use of integrals, you can find out the work done under variable force. So you just need to know this definition. Now, whenever this variable force will be given, in most of the cases, you will be given a graph between force and displacement. That is the next heading, work done by area under graph. And this is important. Many questions have come from this topic and we will be doing it. Work done by area under graph. Which graph I am talking about? It is the force displacement graph. So there will be a graph given between your force and displacement and you will be asked to find out the work done from this graph. So let us say force will be plotted on the y-axis and displacement would be plotted on the x-axis and some sort of graph would be given. I have just drawn a random graph. This is a sine wave I have drawn, but the graph would be very simple. It would be a straight line graph. What you have to do is you will have to find out the area under this graph. You will have to find out the area under this graph. Remember, area under force displacement graph will give you work done. The area which is above the x-axis will be taken as positive area. Work done will be considered as positive, and the area below x-axis would be taken as negative. for the calculation of work. So what you have to remember about this graph, point number 1, area under force displacement graph, area under force displacement graph will give you work done. We understand this, yes or no? Will give you work done. Now this work done would be taken as positive. When will you take them as positive? If it is above x-axis. The area under this graph or work done is taken as negative when it is below x-axis. Give you 1 minute to note this down. You just have to find out area. Area of a triangle is half base into height. Do we know this? Area of a rectangle is length into breadth. Area of a square is length square. We all know this, yes or no? Well done. Then we can move on and see some questions based on the This is the first question. Everyone is ready for the question? This is the first question. You are given a force displacement graph. Remember, it is in centimeters and centimeter per second square. The displacement, the acceleration is given to you. Acceleration is given to you here. Oops, wrong color. The acceleration is given to you. What is happening? Okay, something wrong. The acceleration is given to you and displacement is given to you. Acceleration is plotted here. Remember, force is not given. Acceleration is given, but here mass is given. So from acceleration, you can find out the force. And then you can find out the area under this graph. And then you can get the answer. You can get this, yes or no? So you have 2 minutes to give me the answer. So anyone got the answer? To find the area of this graph, how much is the area of this graph? How much is the area of this graph? Half into base. Base is 8 into height. Height is 20. So you can get the answer as 80. I'm not looking at the units because all the options which are given is in the same unit. So I don't have to worry about the unit. So I'm getting 80. This is the area under this graph, but this is not force. This is acceleration. So what do? I now multiply this by the mass. Either you can do it this way or you can multiply the mass before. So I multiplied that by the mass, 80 multiplied by 100 by 10. 10 is the mass. So I will get 800. Remember, I'm not looking for the unit. I'm just not looking at the unit. The only option that matches 800. Remember, it is not in the same unit. Area acceleration was given in centimeter per second. Distance was given in centimeter. I just multiplied because I looked at the option. They were in the same unit. I don't have to worry about the unit. So the option which is matching is which one? There's only one option which is matching, which is 8 into 10 raised to the power minus 2 joules. So that has to be your answer. Do we understand this? I'm not looked for unit because I don't want to waste my time in converting units and this and that. All the options are different. So I just looked at what number I am getting. And from there, I found out the answer. Do we understand this? Yes or no? So I don't worry about the unit. Remember, the CGS unit of force is Dian and the CGS unit of work is ergs. And this is the question that came way back in the year 1976 about the force and the displacement graph. So now can you tell me the answer for this one? The relationship between force and the position is shown in the figure. The work done by the force in displacing the body from 1 to 5 centimeters. Anyone with an answer? I hope you know how to do this. Yes or no? You'll have to find out the areas. This blue area, this green area, this red area, and whatever color this is, this area. Anyone has the answer? Can anyone tell me how much is this blue area? Can you tell me, bacha, how much is this blue area? It is a rectangle. The height is 10 and the width is 1. So this becomes 10. I should write plus 10 because it is above x-axis. How much is this green area? Can anyone tell me?
+3.
Plus 3. Okay, the green area is plus 3. The height is 20. The width is 1, so it is plus 20. I hope everyone understands this. Then the red area, to find the area of this rectangle, the height is 20 and the width is 1, which is below. So it will take it as minus 20. Then I have to find out this, whatever color this is, maroon or whatever. Height is 10, length is 1. So this is plus 10. I have to add up everything and I will end up with your answer, which is what? Which is the correct option?
Option A.
Option A, and that is the correct answer. Well done, everyone. Everyone got this answer? Yes or no? Anyone got this answer? No one got this answer. Okay, I'll give you a minute to note it down.
Sir, can you explain again?
What you did not understand, beta? What
Sir,
point
I
you
missed the class, sir, due to network problem.
missed the class? You just have to find out the areas. Do you know how to find out the area of a rectangle? Yes or no?
Yes, sir.
So for the blue one, I found out the area of this rectangle. Length into breadth. For green one, I found out the area of this rectangle. You can find out the area of rectangle, na? Length into breadth. Yes or no?
Yes, sir.
That is what I have done, beta. Which area you have a problem? Tell me. For pink one, this is the area. The length is, height is 20, length is 1. And for the last one, the height is 10 and length is 1. In which area do you have a problem, beta? Tell me, in which area do you have a problem? You can see that length or not? Shall I show you the bigger diagram? Yes, you can find out the area, yes or no? This is the blue area. You cannot find out the area of this one, beta? Then this is the green area, beta. This is the red area. And this is the maroon area. Tell me, in which area do we have a problem? The blue, green, and whatever color that is above x-axis, all these three areas are positive, and the area which is below the x-axis, the area is negative. We all understand this? Okay, then I will finish the class here. I was supposed to do one more question, but I don't think we have the time left. So what I'll do is I will carry on this question in the next class. So in the next class, we will be doing this question in the next class. So I'll see you in the next class with the question, and I've already put the question. So this is the question that we are going to start with the next class. We will try to find out the work done by this force. Remember, this is a question from the recent years, and as you can see, they will always give the question in SI units. All these ERCs and all these units will not be there. So we'll start your class with this question in the next class. Hope to see you there. Just have to revise how do you find out area of triangle, rectangle, square, and maybe a circle. It's very simple. You can go through this. Above x-axis, area positive. Below x-axis, area negative. I'll see you in the next class. Take care. God bless all of you. Bye bye.